Before we get to example 1, I would recommend that you read the first page and the box that is right above this, as it will explain what we're going to be doing today. Once you've read through that, then you can get started on the example. Now that you've read the stuff from the first page, let's go through those steps. So step 1, 2, and 3 above, we're going to go through as we go through the process. The first step is to graph the region corresponding to the solution of the system of constraints. So here's our constraints. So the first thing we want to do is graph this and get our shading in the right spots. So let's do that. I'm going to start by doing x is greater than or equal to 0, and that's going to be my vertical line. So that's right here. Then I'm going to go ahead and graph my horizontal line. Y is greater than or equal to 0. So that's right here. And then I have to do the other two. So I'm going to go ahead with the top one. X plus y is less than or equal to 8. And in order to solve that one, I have to just subtract x from both sides. So I get y is less than or equal to 8 minus x. My y-intercept here is 8, so I'm going to go ahead and graph that. That's going to be right here. And my slope is -1, so I'm going down 1 and to the right 1. And I can do that again, down 1 to the right 1, and continue to go through. Again, as many points as you can get is going to be easier to find the vertices, which is our next step. Once you have that, then you're going to get a nice straight edge. Remember, you can use your ID for that straight edge if you need to. If you're not using different colors, then I would recommend you start labeling your lines, which one is which. So the blue line here, you could say this is y is less than or equal to 8 minus x, if you're using something of all the same color. Then I'm going to go ahead and do my other line. So this 2x minus y is less than or equal to 5. If I solve this one, first thing I would do is subtract the 2x. So I get negative y is less than or equal to 5 minus 2x. And then I have to divide everything by a -1. When I divide everything by that -1, my inequality sign is going to flip. So I'm going to get y is greater than or equal to -5 plus 2x. And if I graph this line, I have my y-intercept is -5. Well, I can't graph that on here. I only have the first quadrant since that's what I'm dealing with. So you have to find another way of doing those points. You can try by plugging it in. You can use your graphing calculator and go to your y equals, however you want to do that, but we need to get some points on our graph. So if we want to get a point on our graph, we can start plugging in numbers. So we could plug in 0. -5 plus 0 would be -5. That's our y-intercept. If we plug in, let's try 2. 2 times 2 is 4 plus -5. That's -1. Still not going to work. Let's do 3. If we plug in 3 for x, 3 times 2 is 6. Plus -5 is -1. So we have the point 3, 1. So that's going to be right here. Once I have 1 point, if I can use my slope of my y-intercept, I can go ahead and do that. So I'm just going up 2 and to the right 1. And then I'm going to do it as many times as I can, up 2 and to the right 1. Another option is to just use your graphing calculator, look at your table of values, and you can get your points that way. Remember to use a straight edge so that your lines are as straight as possible, so you're not fooled by anything that might look like a nice ordered pair when really it isn't. So the more accurate you are with your lines, the better off you're going to be in terms of finding your vertices. Then what I want to do is I need to figure out how I'm going to shade. So if I look at my red line and my green line, remember I have to be to the right of my red and above my green, which tells me I'm in that first quadrant. Then if I take a look at the blue line, I want it less than that blue line, which means I want it underneath. Underneath the blue line is this area in here. And then for my orange line I want greater than or equal to. So I want above that line, which is this area in here. So I'm going to go ahead and shade that area that I want, which is this area in here. Step 2 is to find the coordinates of the vertices of the region found. So what that means is any lines that intersect along this shaded region are going to be our vertices. So if you look right here, the red and green line are intersecting, and that's on the boundary of our shaded region. So that point 0, 0 will be one of our vertices. So let's start listing down our vertices. So we know one of our vertices is 0, 0. As we travel along our shaded region, so I'm going to travel up, I get an intersection of the blue line and the red line. The blue line and the red line are intersecting at this ordered pair, and I know this is a nice ordered pair because I've plotted it myself, is the point 0, 8. So 0, 8 is also one of my vertices. As I continue to travel along my graph, I get an intersection of the blue line and the orange line. Now again, my line is probably not as straight as yours, but you should be able to tell on your graph that your line, your blue and your orange line, is intersecting somewhere over here. It's not on a nice corner where I know exactly what those numbers are. So what I need to do is I need to find that intersection of the blue and the orange. So I'm going to find the intersection of the blue and the orange. Oops. To find that intersection, you can either solve the system of equations, or if you want to, you can go ahead and use your graphing calculator. So if I look at those two lines, the blue line and the orange line, I have the blue line, the original, and I'm going to change it to an equal sign. X plus y equals 8, and my orange line is 2x minus y equal to 5. And I have to solve that system in order to find that intersection point. If you know how to find the intersection on your calculator, go ahead and do it that way. If you want to know how to do it on your calculator, please call me over and I will assist you with that. Or you can do it by hand. If I solve this, I should notice right now my y's are opposites, so they will be eliminated. So I can go ahead and add my x's. 1x plus 2x will give me 3x equal to 8 plus 5, which is 13. And if I divide both sides by 3, I get x to be 13 over 3. And then I need to find y, so I can use the fact that x plus y is equal to 8. So I know that 13 over 3 plus y has to equal 8. And if I subtract 13 over 3 from both sides, I get y to be 11 over 3. Don't use the decimal here as that's an approximation. You're going to have to use the fraction. So then I have my other vertice. That intersection point is 13 over 3, comma 11 over 3. Then I'm going to go back to my shaded region. Remember, I've done this point, the red and the green. I got the blue and the red. We just found the blue and the orange. And as I travel along my shaded region, I get to one more intersection point, which is the orange line and the green line. So now what I want to do is find that intersection. So intersection of orange and green. The orange line, once again, is 2x minus y equal to 5. And the green line is y equals 0. Well, this is an easy one to find the intersection of because I already know y is 0. So all I have to do is take that 0 and plug it in for the y above here. So that would be 2x minus 0 equal to 5. And if I scroll up a little bit, if I solve this problem, 2x minus 0 is just 2x equal to 5. Divide by 2 and I get x is 5 over 2. Oops. So I have my other vertice, my last one here, which is the vertice 5 over 2, comma 0. So let's go back over one more time. Step 1 was to graph everything. Step 2 is to find my vertices. To find those vertices, sometimes you'll have to do these intersections. Other times they might come out pretty nicely like the red and the blue line did. It all depends on the problem. My third thing is to evaluate the objective function at each vertex. So that's what I'm going to do next. So if I move this up a little bit, I have my objective function. So we are going to plug the vertices into the objective function. And our objective function here, I'm going to scroll back up for just a second so we can take a look at it. The objective function is this function right here. This f of x comma y equals x plus 3y. Tells you that that's the objective function. Another way to write that, and if you read the front, you would see the notation. We also like to say this is just z equals x plus 3y. You can use the z, you can use the f of x plus y, whatever you decide. So if we come back down here, our objective function that we have, again to remind us, is z equals x plus 3y. And what we're going to do is take each of our vertices and plug them in. Our first vertice that we found was 0, 0. So if I plug 0, 0 in, I get z equals 0 plus 3 times 0, which is 0. If I take my vertice of 0, 8, and plug that in, I get z is equal to 0 plus 3 times 8, which is 24. Take my next one, I have 13 over 3 and 11 over 3. So I would get z is equal to 13 over 3 plus 3 times 11 over 3. And that'll give me 46 over 3, which is approximately 15.3. I want that decimal just so that I know what I'm comparing it to. And then my last vertice that I had was 5 over 2, comma 0. So this would give me z equal to 5 over 2 plus 3 times 0, which is 5 over 2, or 2.5. And what we're looking to do here is we're looking for the maximum and the minimums. When are those going to occur? So if I take a look at all my answers here, I have 0, 24, 15.3, and 2.5. The minimum will occur at the number when this is the smallest, which is 0. And my maximum will occur when this number is the biggest, so that 24 is the biggest. So my answer here is going to be the max occurs at 0, 8, and the max value is 24. The minimum occurs at 0, 0, and the minimum value is 0. And when we move to the next day, what we're going to be doing with these maximum and minimums is we're going to put them into context. So we're going to take the word problems that we used yesterday, apply them with these objective functions to get a problem that makes sense with the numbers that we have. If you have questions on this example, please let me know.